Hi, in this video I'm going to go over the Leetcode problem 2 sum. So the prompt is, given an array of integers nums and an integer target, return indices with two numbers such that they add up to the target. Okay, and here is a prompt. I mean, not a prompt, an example. Okay, so initially my thought is you have an array, you have a target, and you want to see what in the array adds up to the target. Fine. Brute force it. Just try every single solution. 2 plus 7, 2 plus 11, 2 plus 15, 7 plus 11, 7 plus 15, etc., etc., right? That is simple and effective. So it should be really simple to code as well. So for I in range len nums, right? Because you want to go through every element in the array. And then for every element in the array, you want to look at every other element. So for j in range len nums. So you're going through it, and for each pass, you're going through it again. And then in this, you want to see if they add to the target. So if nums I plus nums j add to target, target, then return the indexes, so I and j. That should work. Oh, so I have forgotten to write. So obviously this, what it's done is it's gone, well, 3 plus 3 is 6. So it's 0 plus 0 will give you 6, which is correct. But in the prompt it says each input has exactly one solution and you may not use the same element twice. So you just want to make sure that I and j are not the same. So that means that you're not using the element twice. So if they're not the same, then you can submit. Check that, and that should work. And it does. So let's submit that, and let's see how long that would take. Because it's a brute force, it's going to be substantially longer. It's going to take a while longer than a different method. So as you can see, it's already taking quite a while. Still not loaded. Perhaps that's because I don't have a Leetcode. Oh, time limit exceeded. It must have taken so long. How has it exceeded the time limit? That is insane. So basically, this is very inefficient. What you can do to make it a lot more efficient is so what we're doing here is for I in range len nums for j in range len nums. So we're comparing. Oh, there you go. 9492. So that's very, very slow, right? Only faster than 5% of the submissions. Memory is just fine though. So what I've done is I've done 2 compared to 7, 2, 11, 2, 15, and then we've already compared 2 to 7, right? And then when we get to 7, we're comparing 7, 2, 7, 7, 7, 11, 7, 15. Sorry, not 7, 7. So when we get to 11, you're doing 11, 2, 15, 11, 7. But we've already done 11, 7, 11, 2. You know what I mean? So what you can do is you can go from, as you pass through it, you can go from the number to the rest of the numbers each time. See what I mean? So you can go for j in range I the numbers. That way, it will only compare to the rest of the numbers that it hasn't already compared. Because we're making a lot of comparisons twice, which you don't need to do. So let's see how that fares. And there you go, a lot faster, right? It's almost half the time. But this is still really, really slow because it's a brute force. It's O(n) squared, so it's going to take a long time. So what you can do is not this method. This is not a good method, right? So what should you do? Well, here's something to think about. If we want A plus B to equal target, right? So if A plus B equals target, then B equals target minus A. And that's something I want you to think about, okay? Gonna hashtag it as a comment, right? So I'm gonna create a dictionary called complements, where B is the complement of A to make it a target. So complements is a dictionary, right? And then I want to do for I in range len nums. So same as last time, just going through, right? But we're not going to do it for it this time. This time we're going to calculate the complement. So complement equals target minus the current number, which is nums I, right? The number that we're currently looking at, and then now we have the complement. So this is the number that we want, right? So let's just pass this as if with this example. So it's going to go through 2, and it's going to go for I in range let none. So I is going to be 0, and it's going to go looking at 2, right? The number is 2. So complement equals 9 minus 2, which is going to be 7. Okay. And then what we want to do is put 7 in the complements list. So complement is equal to the index, right? I, yeah. So what we've done is we put the key of 7 as 2, okay, in the dictionary. And then we want to check if, so what we want to do is if the complement is in, if the number is in the complements, sorry, if number, so the number would be nums I. If that's in complements, then just return that. So I'm doing. So if the number is in complements, then return the 2 numbers. So I mean the 2 indexes. So the index should be I and complements number. Okay. And then if it's not in complements, then add it to complements, right? Right? Yeah. Yeah, there you go. And let's see if that's a lot faster or not. See, that was really fast compared to the others. Much faster, right? A lot better than the 9,000 milliseconds, 4,000 milliseconds. It's literally the 100th of the time to the first one. So that's really good, isn't it? It's a lot better, a lot more efficient. I hope that makes sense. I hope you understood it.